Hello, Keith Rucker here, VintageMachinery.org. Guys, today I'm working on a little project out here in the shop, and this is something I started on a while back and never did really get finished. I'm wanting to make a little batch of key plugs. This is for a Crescent Machine Company jointer or planer, the larger planer heads or jointer heads, anything above 8 inches, took this particular key plug to actually lock the knife in the cutter head in place. And I've made a batch of these. It's been quite a few years ago, and I've had several requests from people that wanted some more of these, that needed them for restorations they were working on, and decided to make some. So I cheated a little bit this time. Last time I made them all from scratch myself. This time I had my buddy Tom Zeckleman, who has a little CNC machine. He actually cranked out a bunch of blanks for me. It's fairly simple. I'll show you the drawing here in just a second. Let me kind of show you what he did. So this is the part that I'm making, and this is actually one that I had made previously, and it's a finished piece. What I did was I had Tom just make the blanks for me on his CNC lathe. It's just a repetitive job. It's not something that can't be done on a manual lathe. The original ones I did on a manual lathe, but this is a job that just screams production type machining, and a turret lathe, the CNC lathe, something like that would be perfect for it. Fairly simple operation. Basically, you come in here, you put this chamfer on the end, you drill and tap it, and then cut it off the length with a parting tool. Very simple operation, but doing them manually by hand and cranking out lots and lots of them is quite time consuming. So like I said, I had him make the blanks. And then the final step, and what I'm going to be doing, is cutting this angle on there. You see that angle? That's a 76-degree angle. And it's on there. This is what actually wedges the key plug in place over on the cutter head. And I think what I'll do is, I've actually got a Crescent jointer here in the shop. I'm going to take you back there and show you where these go and how they work, so you get a better idea of what they're for. This is my Crescent 16-inch jointer, the cutter head on here. And if you look on the cutter head, there's a knife, there's this what's called a throat plate that's in here, and then the key plugs fit down in these sockets. There's holes drilled down in the casting here, or not the casting, that's steel, but it's drilled down in there at an angle. And what you do is you put a set screw inside of this piece here that's threaded, and whenever you crank down on that set screw, it pushes this up and creates a wedge, and it basically wedges this throat piece over to the knife, and that's what holds the knife in place. They're very effective. They hold it in there really well. This particular cutter head here's got 4 sets of knives on it, and 4 key plugs per knife, depending on the width of your jointer or your planer. The number that you need varies. Like I said, this is a 16-inch machine, and some machines are, particularly like a 24-inch planer, they're going to be much wider. A 12-inch jointer probably would only have three key plugs in it, etc. But that is what we're making, and for whatever reason, sometimes these go missing. People will get a machine, they don't have any key plugs, someone takes out the knives, and the key plugs get lost, or they get damaged, or whatever, need to be replaced. And I've had several requests for these over the years. I've made a batch several years ago, and anyway, we're going to be making some more. When I did this job before, I actually made a little fixture here to hold these key plugs in a vise for the milling operation. And what I did is I just took some aluminum, made some soft jaws that fit into this particular vise, and I went over to my vertical milling machine, and I tilted the head back to that angle. I think it was 76 degrees, I think is what it was, and took an end mill that was the same diameter as this, and went down through there and cut that slot into it very carefully. And what you got now is that key plug will go right down into that pocket. I clamp down on here, and then using the mill machine, I just cut the top of that off. Now I'm going to use the horizontal mill. You could do this on a vertical mill. It really doesn't matter. But when you do that, We'll just put one of these in. When you do that, when you get through, it mills it off at that nice angle. You pull it out, and voila, you have that precise angle cut on there. So we're going to go get this set up over on the horizontal milling machine, and I've got a day of production work ahead of me. I hate doing production work, but sometimes that's what you got to do. So we're going to crank all these out today. So first thing I want to do is come over here and tear down my arbor from my last job I had on the machine. I start by removing the nut. I've mentioned this before, but you always want to tighten and loosen this when you have the overarm support here. It gives it support and keeps you from bending your arbor. There's so much leverage out here. If you try to tighten and loosen that with it out the support, you can bend that arbor and cause problems down the road. We'll loosen this up and just slide that off. Now we'll pull our stuff off the arbor. That's the bearing. Got some spacers in here. This was the last cutter that we used, and I'm just going to go ahead and pull these spacers out as well. Those are kind of stuck on there. I'm just going to leave them in place. I'm going to put these up real quick. For this job, I'm going to have to use a different arbor. The size of the cut tool I'm going to put on there is different size than the arbor that's on here. So we're going to remove the arbor. There's a drawbar in the back of the arbor. I'll just loosen that up, and this whole arbor, it's on the 50 taper, just comes right out. The arbor that was in there was a 1-inch arbor, 1-inch diameter. I need 1.25 inches. So first thing I'm going to do is just lightly wipe out the socket there. I also wipe the 50 taper that goes in there, and then we'll tighten up the drawbar in the back of the arbor and tighten it up so that it can pull in good and tight. Get my wrench. All right, new arbor is installed. So now we'll go ahead and start building this arbor. I've put some spacers on here to get my cutter in the right position. So just a couple of spacers there. For this job, I'm going to want my arbor running counterclockwise. So I want to make sure I get my cutter oriented, and we're going to be using this slab cutter. I've used this recently on a different project. I want to make sure I've got a key in here. There's a key that fits in the keyway, and we'll put that in place. And then slide our cutter on there. We'll put another spacer on the back side. And then I'm going to put my bearing in here. And then this arbor is a little bit long, so we'll just put some spacers on the end to get out here to the nut to tighten it up. And I'll just loosely put this on here. Again, we don't want to tighten it up until we get our overarms on. I'll run my overarm supports out to the end. Now I'll put my overarm support on the overarms. Always put them on the top 2 bars first, and then I'll pull it over the bearing. It just lines up better. Put some oil on everything. This overarm support has a oil reservoir built into it that will self-oil it, but I always like to make sure I have some oil to start with. And now we'll just pull the overarm support right over that bearing, and voila, we're in place. tighten up the overarm support so they can't move in and out. And now tighten up the nut on the end to get our arbor tight. There we go. One thing that I'll comment on right here is that notice that I've got my bearing in not on the very end of the arbor, but kind of in a little bit. In this case, I don't need all this space. This arbor's a little bit longer than what I probably need, but I would rather support it closer to the cutter. I don't have as much vibration and stuff in here than to put it way out at the end. In this particular setup, I'd much rather have this sticking out the end. It's not hurting anything, but you get better support getting the bearing support closer to the cutter, and I think we're in good shape there. Let's swap our vise out now, and I think we'll be ready to start making some chips. Go ahead and loosen this vise up, and the soft jaws that I have don't fit this vise, so I need to put the actual vise over there on here. So we'll just go ahead and pull this one off. Make sure we got our table nice and clean here. Don't want to put it down on a chip or something like that. Now I'll wipe down the bottom of this vise over there on the bench before I brought it over here, just FYI. And I think I'm going to need some longer bolts. I think these will be okay. All right, so for this particular setup, I'm not worried about the vise being trammed in because we're just cutting it flat across the top. Being in particular orientation doesn't matter, so I'm just going to pull the vise toward me so that it kind of gets up against the back of that bolt, and that'll be close enough for the job that we're doing here at hand. Like I said, it just doesn't matter, so I'm not going to spend the time to tram those jaws in. All right, I think we are set up. Let's get this machine ready to roll. I remember from last time I did this, I had it where it basically was just skimming the top of this piece, and that was the proper height. So I just lowered my cutter down until I just came in contact with that. That should give me a good starting point. I'll cut one or two here and measure them and make some fine adjustments as needed. So I've got my cutter turning. The reason I've got it running in the direction I am is I want the pressure of the tool to be pushing it down into the seat. If I come the other way, I'm pushing the tool out, and I could, if I didn't have a good grip in here, cause that part to creep up and be out of tolerance. So just good to make it go against a solid seat as much as possible. All right, we've got our Arbor running at, what is it? 195 RPMs. I think I got my feed set at 4.5 inches per minute. Let's come down here. I do want to, I am going to put a little shot of cutting oil in here just to help. And let's see what it does. Right. pull that one out. And I'm going to make a measurement and make sure we're in spec. So according to the drawing, this measurement here needs to be 712 to 715 thousandths. And it looks like I'm right on 712. It's kind of hard to get a measurement on there. So tell you, I'm going to probably just bump the table down about 1 thou, so I'm not right on the edge of that. Right on the edge of that tolerance. That should put me about 713. So we'll run another one and double check it. The first one's in tolerance. Let her cut across. Check this one. Yeah. That one's a little bit, about 713, so we're good. All right, we're gonna let this thing roll. We put our chamfered end down. Tighten up the vise and let her roll again. Gotta love the horizontal mill for being able to hog off a bunch of material in a hurry. And that slab cutter just leaves a beautiful finish. I've got a batch of these finished up. I don't have them all done, but I got a good many of them finished up. And the next step here is I want to do some deburring. I just want to kind of hit these machined edges, break them over, just soften them up. And to do that, I've got some of these brush wheels. These are ATB brush wheels. These are made by Osborne. I've got a fine one over here. And I can't remember if this is a medium or a coarse one, but these are great for doing deburring operations. And I'll just come in here and use them kind of like you would a Scotch-Brite wheel. But I like these brush wheels a little bit better for this kind of an operation. So the bottom's already been deburred, so I'm just going to go through these and do them one at a time. Well, guys, in full disclosure, the reason I didn't finish all of those parts over here on the horizontal mill is I ran into a problem with my rapid traverse on the mill. It's been giving me trouble for a while. And I actually did some work to it about 4 years ago. However, well, the problem was there's a spring clutch pack inside the mill that allows the rapids to slip whenever they get under too much load. The original springs in my clutch pack had wore out, and it was in really, really bad shape when I got it. I took it apart at one point in time, put new springs in it, but they weren't the right springs. I knew they weren't the right springs, but they were the best springs I could find at the time. And it was a great improvement over where I was at, but it didn't really fix the problem. Here I am 4 or 5 years later. I pulled it all back out. I was able to find the correct springs this time, so I'm in the process now of rebuilding that clutch pack again. Hopefully I'm going to have the rapid traverse issues resolved on this machine when it's done. And we'll be doing a video on the tear down and the repair of the clutch pack on this thing separately. It is in progress at the time of this video filming. So with that, guys, that's going to be a wrap on this episode, and I will finish up this job once I get the milling machine back up and going. And on the Crescent key plugs, I'm going to have plenty of extras of these things, guys. If anybody out there is looking for some, shoot me an email right down here, and I'll let you know. I've got to work up a price on them based on what my cost is, plus hopefully making a few dollars on them, but try to keep them reasonably priced at the same time. So if you're looking for some, let me know. I may or may not have them by the time you see this video, depending on how far in the future it is, but I am making up a pretty good, I'm going to have over 100 of them whenever we get done here, so we should have enough to last for a while. And with that, guys, that'll be a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already. Comments are appreciated, as are those thumbs ups. So guys, we'll catch you on the next video.